Welcome to YQ Academy Collections Framework Java Interview Questions and Answers. 1. Explain HashSet and its features. HashSet is an implementation of the set interface in Java that stores elements using a hash table data structure. Features of HashSet. 1. No duplicate elements. HashSet does not allow duplicate elements. If you attempt to add an element that is already present in the set, the insertion will be ignored. 2. Unordered collection. HashSet does not maintain any specific order of elements. The order of elements in a hash set may change over time as elements are added or removed. 3. Fast lookup. HashSet provides fast access to elements based on their hashcode. It uses hashing to distribute elements into different buckets, allowing for efficient lookup operations like add, remove, and contains. The performance of these operations is generally constant time-on, making HashSet suitable for large collections. 4. Null values. HashSet allows the inclusion of null values. You can add a null value to a hash set, and it will be treated as a single element in the set. 5. Not thread safe. HashSet is not synchronized and is not thread safe by default. If multiple threads access a hash set concurrently and at least one of them modifies the set, external synchronization is required to ensure thread safety. 6. Implementation of hashcode and equals. When using objects as elements in a hash set, it relies on the hashcode and equals methods defined by the objects class to determine equality and to generate hashcodes. It is important to override these methods properly for custom objects to ensure correct behavior of HashSet. 2. Explain TreeSet and its features. TreeSet is an implementation of the set interface in Java that stores elements in a sorted and ordered manner. Features of TreeSet. 1. Sorted collection. TreeSet maintains the elements in sorted order. The order is determined either by the natural ordering of the elements if they implement the comparable interface or by a comparator provided during the TreeSet's creation. 2. Red-black tree. TreeSet internally uses a self-balancing binary search tree called a red-black tree to store the elements. This data structure ensures that the elements are always sorted, allowing for efficient insertion, deletion, and retrieval operations. 3. No duplicate elements. TreeSet does not allow duplicate elements. If you attempt to add an element that is already present in the set, the insertion will be ignored. 4. Null values. TreeSet does not allow null values. If you attempt to add a null value to a TreeSet, it will throw a null pointer exception. 5. Navigable operations. TreeSet provides several navigable operations, such as finding the first/last element, finding elements greater than / less than a given value, and retrieving a subset of elements based on a range. These operations make TreeSet suitable for scenarios where you need to perform range-based queries on the elements. 6. Not thread safe. TreeSet is not synchronized and is not thread safe by default. If multiple threads access a TreeSet concurrently and at least one of them modifies the set, external synchronization is required to ensure thread safety. 7. Performance. The performance of TreeSet operations is generally logarithmic O log n, making it efficient for large collections. However, the performance may degrade if the element's natural ordering or the comparator's implementation is inefficient. 3. When do we use HashSet over TreeSet? 1. Unordered collection. HashSet does not maintain any particular order of elements. If the order of elements is not important to your application, and you just need a collection that efficiently stores and retrieves elements without duplicates, HashSet can be a good choice. It typically provides better performance for insertion, deletion, and retrieval operations compared to TreeSet. 2. No custom sorting. If you don't need the elements to be sorted based on a specific ordering or custom comparator, HashSet is a simpler choice. HashSet uses the hashcode of elements to determine their storage and retrieval, making it suitable for scenarios where you don't need explicit sorting. 3. Handling null values. HashSet allows null values, whereas TreeSet does not. If your collection needs to handle null values, HashSet is the appropriate choice. 4. Thread safety. If you require thread safety, HashSet can be used in a synchronized manner with external synchronization, e.g., using collections. Synchronized SIT. On the other hand, TreeSet is not thread-safe by default and would require additional synchronization if used in a concurrent environment. 5. Performance considerations. HashSet typically offers better performance for most operations, e.g., add, remove, contains, compared to TreeSet. TreeSet's performance is better suited for scenarios that require sorted order and range-based operations, but it might have a higher overhead due to maintaining the sorted structure. 4. What is Linked HashSet and its features? Linked HashSet is an implementation of the set interface in Java that combines the features of HashSet and linked list. It maintains a predictable iteration order that is based on the insertion order of elements, while still providing constant time performance for the basic operations of add, remove, and contains. Key features of Linked HashSet. 1. Order of insertion. Linked HashSet maintains the order of elements based on their insertion order. When you iterate over a linked HashSet, the elements will be returned in the same order in which they were inserted. 2. No duplicates. Like other implementations of set, Linked HashSet does not allow duplicate elements. It ensures that each element in the set is unique based on its equality. 3. Backed by hash table. Linked HashSet internally uses a combination of a hash table and a linked list to provide fast access and maintain the insertion order. The hash table allows constant time performance for add, remove, and contains operations, while the linked list maintains the insertion order of elements. 4. Iteration performance. Iterating over a linked HashSet is efficient because it maintains a doubly linked list that allows iterating forwards and backwards. It provides predictable and consistent iteration order, making it useful in scenarios where the order of elements is important. 5. Inherits from HashSet. Linked HashSet is a subclass of HashSet, so it inherits all the basic functionality and performance characteristics of HashSet. It adds the additional feature of maintaining the insertion order. 6. Thread safety. Linked HashSet is not thread-safe by default. If you need to use it in a multi-threaded environment, you should use external synchronization, e.g., wrapping it with collections, synchronized SIT to ensure thread safety. This is the end of our Java interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.